Just like you can't just set up your own pirate radio station, you can, but you're not allowed to. There's only certain bands that are allowed to be transmitting them before you start interfering with radio communications to sort of get it. So there's that sort of one approach. Now, how you can actually configure your individual sensor nodes, you've got different topologies of that network. You can have a really simple star network where the central one acts as a coordinator. That's the thing that's perhaps sort of got a power supply that can listen to a variety of people and then communicate with the internet. That might be your gateway node. Or perhaps you might have this sort of mesh network where you've got quite a few who can coordinate, but then pass it over perhaps to one in another network, another little sort of star things. Now that right-hand side is a bit how Bluetooth works. With Bluetooth, you can only connect 8 devices simultaneously. If you want to communicate with more than 8 people, you can't. The way to do it is to say, well, one of those 8 can communicate with perhaps 2 networks, and it passes its information over. Just like in here, you can say, well, the maximum size in here is whatever it is, 120 people. And that's the maximum I can communicate to in here. If we want any more, we're going to have to use next door, and perhaps have somebody who's relaying messages here to next door. Now that's a bit sort of trickier, because at the moment, you're all passive listeners. You're sitting there, you're absorbing stuff. You don't actually have to do any retransmitting of it. And that's the bit that can take a bit of sort of energy. If you knew you had to pass that message on, you might have to write it down and then sort of pass it on. And it takes a lot more effort to be able to listen and rebroadcast. But it depends on what we'll look at the sort of different approaches depending on what type of sensor network you want to put together. Whether it's something where you can just communicate with things within a set radius. Now that's how the one that I showed the other week, the heating controller works. That has a centralised gateway, and then all the heating controllers on the radiators transmit over it, and it can communicate just within a house. The other side there, the mesh, is a bit more how the Hue light system works, because each light bulb not only can send its data, but it can listen and retransmit. So they can act as sort of relaying on, and effectively you've got an infinite size mesh that the light bulbs can work with. You're not limited just to the 30 meters or whatever it is that an individual one can work on. So you can either have these sort of modes for transmission of what's called a beacon node, where somebody's just broadcasting out their information and anybody can pick it up. So anybody's perhaps within range of me at the moment, they can pick up the information to sort of send out. They sort of they're the coordinators. They're transmitting a beacon, perhaps some sort of synchronization part to it, so you know what rate these things are going out. Before I come in here, I might say, right, I'm going to speak at this sort of speed. I could speak at this speed, but it would take forever. Yeah, and so by that time, speaking slowly there, people are sort of dropping off or whatever. You want me to speak at a certain rate, so you need to have a sort of speech rate, transmission rate, whatever you sort of mean for it, because otherwise it might be sort of too fast for it. So when other nodes are detecting it, they scan for a beacon, they scan for this transmitter, and then use this CMSNA, this thing to sort of decide how fast people are speaking, to sort of find out what the transmission rates are. Similar things already happen with Wi-Fi. You might know that there's 2 versions of Wi-Fi for your router. One that's broadcasting out at so many megahertz, and I can't remember off the top of my head, but another one that transmits faster. And it depends what type of device is listening to decide which one it'll pick up on. Some Wi-Fis are a lot faster than others. And your device has got to decide which Wi-Fi is the sort of fastest to it. But if we just have a look at the sort of idea of how these are working with, what they're trying to do in broadcasting terms, you've got these sort of beacons broadcasting out, and some people listening and some people not. If I'm sending this out, I've got to decide, when are you going to listen to me? Now, it may be that we've got this hour allocated now for you to listen, and that's when you'll absorb the information. It's no good me coming in here at 2 o'clock this afternoon and broadcasting this information out. Nobody's sort of listening for it then. You're all too far away, you're all in different sort of parts to it. So what the network has to do is just broadcast out at certain contention-free periods when they know that somebody's going to be listening to them. So when they know that their receiver is, I'm sort of listening for it, or other times when there's some sort of contention for that, when it's dealing with something else. Because you can't listen all the time. Listening takes some sort of energy. During the other time, you might be transmitting. People who can listen and talk at the same time, that's sort of all good, but in general, you're just sort of doing one at once for it. Let me just basically, when you're sort of transmitting, you've got to sort of broadcast out a signal, and then the listener will say, "Yeah, I'm ready to have it," and then the coordinator will send the data out, and the network says, "Yeah, I've received that," to sort of get it. The non-beacon mode is where the listener says, "Can you send me some data now? I'm listening now." And that's a sort of on-demand one. And your coordinator has got to say, "Okay, yeah, I'll send you the data." That's rather like, instead of me broadcasting out to you at a set time in here, you all individually decide to come to my office and say, "I want that lecture on network transmissions now, please." And I sort of give it you individually. So it's not a particularly efficient way of doing it. Now, what we're going to be doing in the lab sessions is that we'll actually be implementing this non-beacon mode at first. You'll be transmitting out to a server your data, but the thing that's going to act upon it has got to keep going asking the server, "Have you got some data for me? Have you got some data for me?" So your door lock we'll go to the server and say, "Is the door open or closed?" So it comes back, "It's closed." Okay, well, I won't do anything. Go back to the server a second later, "Is the door open or closed?" "It's still closed." Eventually, the door lock will ask the server and say, "Is the door open or closed?" Somebody will have sent an open request, and the thing can act upon it and perhaps sort of open its door. So in that way, the network device is constantly polling this coordinator for its sort of data. Well, the coordinator gets a lot of messages then, and a lot of which may not necessarily be of interest. A better way is just to broadcast it out, and then anybody who wants to listen for it can do that. This one's using the database server, one of the methods that you'll implement in your assignment. This other one uses something called a message server, notably some technology called MQTT, to broadcast out to anybody who's effectively listening, and you set up a series of listeners on your network device. So I'll come back to a diagram something like that in the labs for sort of working with. Now, luckily, we don't really have to deal with any of this hardware part to it. This isn't an electrical engineering class, this isn't a network engineering class. We're more in IoT applications. We're dealing with existing protocols and how they work. All we have to do is to get to grips with how the APIs work that interact with this. So we'll have to know within our Java, say, how to make an HTTP call. Because that's built in. Remember that HTTP client that we've got that sent its data off? We just have to know how that works. We don't need to know further down, how did Java implement that library for it? Somebody else has written that library for us to interact with the basic sort of hardware for it. And similarly, when we start using Zigbee, Bluetooth, LoWPAN, and all these other ones, we'll have an API that we call upon, and we then just write our application. So we're really dealing with those at that top level, the application level. The application support are our APIs that allow us to interact with the network. On this particular course, we're not dealing with that sort of 7-layer architecture of the network model and all that sort of stuff. It may be, if you're venturing over onto the hardware side, network engineering side, you may want to get into that. It's just outside the scope of what we're working with here for you. So what I want to just quickly flip over to the next set, which looks at this is the chapter 4. I'll probably venture this over into next week. Might manage to get through the network part today. This, as I say, is a bit more on the techie side than the other sort of either the practical parts in the labs or the more sort of high level stuff is. This is on how we have to arrange our network and operating system, our system software to work with. So it looks at the networking module part to it, how you might route things through. Generally, not something that you would have much control over, because it's normally dealt with by the network module itself inside.